Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of identifying proportional and non-proportional functions. This is standard 8.5H in the great state of Texas, and we are using item number 26 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we need to find an equation that represents a proportional relationship between x and y. You notice each of our answer selections have an x and y, so really the key is going to be in that word proportional. And if you know what that word proportional means, it's going to be a really easy problem. But let's say we don't. What can we do to solve this problem? Well, we've got a whole bunch of equations, and they're all going to be linear here. So let's just, let's open up our calculator. Let's use Desmos. Let's graph some of these things. Let's just see what happens when we graph these and see if that helps us. All right, so we're going to say y equals x plus 15. All right, we're just going to graph all four of these, and then we'll kind of zoom out and see what we see. Y equals x divided by 2, right? So now we've got a y equals 2, and then in parentheses, x plus 4, x plus 4. And then let's get this one, y equals 5. All right, so we've got all of these here. I'm going to zoom out a little bit because that red one's kind of off. Okay, so we are looking for one that's different. It needs to be proportional, and we are looking for one that is different than all the others. So what I'm noticing here is I'm noticing the red one and the green one kind of do the same type of thing. The y equals x plus 15, and then the y equals 2x plus 4. They both kind of do the same thing. So really, there's nothing that distinguishes one for the other because I'm looking for one that's different. So let's take those two off. I'm noticing my purple and my blue one are definitely unique. The y equals x over 2 and then y equals 5. And the reason why I am picking this y equals x over 2, even though I took away these other ones, is because y equals x over 2 goes through the origin, and that tends to be kind of a sacred space when we're graphing problems, so that could be one that I'm looking at. So I'm looking at that one in addition to this y equals 5. So let's go back to our problem here. We'll see if we can figure anything out here that can help us. Because take a look at this. Right now, the two we're looking at are the y equals x over 2 and then the y equals 5. Well, here's the problem with y equals 5. I need to find a proportional relationship between x and y. And take a look at y equals 5. There's no x. It's not there. It's literally just the equation of a straight line, y equals 5. So I'm thinking it's not going to be that. So I'm kind of leaning towards that y equals x over 2, assuming still I don't know what proportional means because it goes to the origin. That's kind of unique. The other two don't. Let's look at our reference material because there's one piece of information that can still kind of help us. Now, it doesn't say proportional, but we do know on our linear equations we have slope-intercept form, y equals mx plus b, and direct variation, y equals kx, right? And they're both very similar. Y equals mx plus b, and then direct variation, y equals kx, right? The m and the k kind of serve as the same function here. The difference is that slope, that intercept, that plus b. That's the difference between these two, okay? So this direct variation, for those of us that do know our vocabulary, is a proportional relationship. So when you're talking direct variation, you are looking at y equals kx, which is this. This is really y equals 1/2 x. They just took that 1/2 and made it x over 2. It's the same thing. And that's what we're looking for because that's a directly proportional relationship. So our answer is B.